Good day, esteemed researchers and curious minds tuning in from around the globe. We're diving into the fascinating world of language, understanding with the paper, Precise Zero-Shot Dense Retrieval without Relevance Labels. This groundbreaking research challenges the necessity of numerical relevance in retrieval tasks, introducing the innovative HyDE model. It's a thrilling exploration into how we can leverage language learning models to revolutionize relevance modeling. Stay tuned as we unravel the implications of this research. Let's begin. Our research introduces a new paradigm, a unique interaction between language learning models, or LLMs, and dense encoders, or retrievers. This approach challenges the conventional understanding of numerical relevance in language comprehension and retrieval tasks. Now, let's consider the existing models. Dense retrievers and self-attentive re-rankers typically model relevance scores using vector similarities and regression scores. However, we propose a thought-provoking idea. Could numerical relevance be merely a statistical artifact of language understanding? This question opens up new avenues for exploration in the field of language modeling and retrieval. The HyDE model, a novel approach we've introduced, captures relevance through a natural language generation model and the language generation process. It's implemented using InstructGPT and Contriever models and has been rigorously tested on a variety of datasets. Now let's talk about performance. The HyDE model is as effective as dense retrievers that model numerical relevance scores. As the search log grows, it can gradually replace a supervised dense retriever. And here's the interesting part. Less common and emerging queries are handled by the HyDE backend. This makes it a versatile tool in the ever-evolving field of information retrieval. In essence, HyDE is not just a theoretical concept, but a practical tool that can adapt and evolve with the needs of a search system. It's a testament to the power of language understanding and generation in modeling relevance. Our research primarily addresses the challenge of dense retrieval in language understanding tasks. Dense retrieval, as some of you may know, involves retrieving documents using semantic embedding similarities. It's been successful in various tasks like web search, question answering, and fact verification. However, zero-shot dense retrieval, where the system is not trained on any specific task but is expected to perform well on new tasks, remains a difficult problem. Now let's take a look at this figure. It provides an overview of our proposed solution, the Hypothetical Document Embeddings model, or HyDE for short. This model is unique in that it serves all types of queries without altering the underlying GPT-3 and Contriever Contriever models. It introduces a novel approach to modeling relevance in language understanding tasks, replacing numerical relevance with language generation models. This innovative approach allows us to tackle the challenge of zero-shot dense retrieval head-on. Existing models have limitations, as they all involve modeling relevance scores between a query and a document. This numerical relevance might just be a statistical artifact of language understanding. Our proposed solution, HyDE, aims to overcome these limitations. It's designed for fully zero-shot dense retrieval systems and decomposes dense retrieval into a generative task and a document-document similarity task. This means the query document similarity score is no longer explicitly modeled. HyDE has unique features that set it apart. No model is trained in HyDE, and relevance labels are not needed. This opens up exciting possibilities for generalizing HyDE to more sophisticated tasks like multi-hop retrieval, question answering, and conversational search. This approach could revolutionize how we think about and implement search systems. Let's delve into the performance of the HyDE model. It's fascinating to note that HyDE offers a performance that is comparable to a fine-tuned model. This is significant because it suggests that even a weak retriever could theoretically suffice, as the natural language understanding and natural language generation models become stronger. This opens up a new perspective on how we approach and understand the capabilities of these models. Our research introduces a novel approach called Hypothetical Document Embeddings, or HyDE. This model breaks down the process of dense retrieval into two distinct tasks. The first is a generative task, handled by an instruction-following language model. The second is a document-document similarity task, managed by a contrastive encoder. Let's delve deeper into the generative task. Here, the query is fed into the generative model, which then creates a hypothetical document. This process captures the essence of relevance by generating an example of what a relevant document might look like. This innovative approach allows us to tackle dense retrieval in a new and effective way. In our research, we propose a unique approach to dense retrieval, pivoting through hypothetical document embeddings, or HyDE. This process involves two key tasks. The first is a generative task, where an instruction-following language model is used to create a hypothetical document. This document, while not real and potentially containing factual errors, is designed to resemble a relevant document. The second task is the document-document similarity task. Here, the hypothetical document is encoded into an embedding vector. The encoder acts as a lossy compressor, filtering out any extra or unnecessary details. This vector is then used to search against the corpus embeddings, retrieving the most similar real documents. This innovative approach allows us to bypass the need for explicit query document similarity scoring, instead focusing on natural language understanding and generation tasks. Our research introduces a novel approach, HyDE, which leverages the power of InstructGPT and Contriever models. InstructGPT is utilized for open-ended generations, while Contriever is employed for retrieval tasks. We've tailored different instructions for each dataset to ensure optimal performance. In terms of experiment design, we've tested HyDE on a variety of datasets, including TRECDL19, DL20, BEIR, and Mr. Tidy. We've compared the performance of HyDE not only to a fine-tuned model but also to other dense retrievers. This comparison allows us to understand the strengths and potential areas of improvement for our model. In essence, our research is a step towards understanding how language understanding and generation models can redefine the concept of relevance in information retrieval. We're excited to see how this approach can be further applied to more complex tasks. Our research introduces the HyDE model, a novel approach that leverages the power of InstructGPT and Contriever models. We've put this model to the test on a variety of datasets, including TRECDL19, DL20, BEIR, and Mr. Tidy, and the results have been promising. HyDE's performance is comparable to dense retrievers that model numerical relevance, and it even matches the performance of a fine-tuned model. One of the key advantages of HyDE is its ability to adapt as the search log grows. Initially, it can handle queries with performance comparable to a fine-tuned model. As the search log expands, a supervised dense retriever can be gradually introduced. This means that as the dense retriever becomes stronger, it can handle more queries, leaving only the less common and emerging ones to the HyDE backend. Perhaps one of the most exciting aspects of HyDE is its ability to eliminate the need for relevance labels. This opens up new possibilities for how we approach search systems and how we can continue to improve them in the future. We've introduced a novel interaction paradigm between large language models and dense encoders/retrievers, paving the way for a new approach to information retrieval. Our model, HyDE, captures relevance through natural language generation, offering a fresh perspective on how we understand and model relevance. In our experiments, HyDE has shown to be as effective as traditional dense retrievers, demonstrating its potential in practical applications. Importantly, HyDE eliminates the need for relevance labels, a significant step forward in reducing the dependency on labeled data. In essence, our work with HyDE opens up exciting possibilities for future research and practical applications in the field of information retrieval. We look forward to seeing how these ideas evolve and are applied in new and innovative ways.